So now that we know that the smallest part of the elements are the atoms, and we know the symbols for elements, we have to go one step further and use symbols that are going to be a little bit more explicit about what's contained within the atom. Recall our models that we've gone through: Dalton's solid indestructible sphere, J.J. Thomson's plum pudding model, and Rutherford's nuclear model. So we'll work kind of on the assumption of Rutherford's nuclear model for the moment, although we're going to assume that the neutrons have been discovered. So remember, Rutherford's nuclear model is that all the mass is concentrated in the center of the atom, and then the electrons are orbiting around the nucleus. Orbiting isn't a great term for us to use currently, but for the moment, we can think about it that way. All right, over on the right, we see a symbol for the element Cl, which hopefully you recognize as chlorine. The number on the bottom, the 17, is called the atomic number, and that's the number of protons. The number on the top is referred to as the mass number, and that's the number of protons plus neutrons. So if there are 35 protons plus neutrons, 17 are protons, that would leave us with 18 neutrons in the chlorine atom. If we have a neutral atom, then we would have the same number of electrons as protons. So in a neutral atom, you wouldn't see a charge on this. If this were not a neutral atom, say this were a chlorine ion, we would see a 35, 17 Cl minus. And so the minus indicating that there is more negative charge than there is positive charge. The only way to do that is to add an electron. The atomic number, being the number of protons, indicates that if you change the number of protons, you would change the element. So the Cl minus, you might think, well, could I just take a proton away? Well, if you took a proton away, that would be element number 16, which would be sulfur. So anytime you gain, you look at a charged species, you're always looking at gaining or losing electrons. The other term that we need to be familiar with is isotopes. So you see that this chlorine has 17 protons, 18 neutrons. There is another isotope of chlorine, so it would be Cl17, but instead of 18 protons, there are 20 protons. Or sorry, instead of 18 neutrons, there are 20 neutrons. So we would have a Cl37, chlorine with a mass number of 37, indicating then that we would have 17 protons, as we would have to have for chlorine, but now we have 20 neutrons. Okay? Those two would then be referred to as isotopes. Just as you would, if you saw two twin people, you would refer to them as twins. These would be two isotopes of chlorine. So you'll want to do a few practice problems, just being able to use these symbols to determine the number of protons, neutrons, and electrons. And if you knew the number of protons, neutrons, and electrons, you could create this symbol as well.